today. Again, we're going to define all this stuff here, review it, but once in a while, the book's going to go through, if you forgot your rules of divisibility, here they are, right here. The book's going to show their different methods of building trees too. So it's out there, at least, especially this part, if you can't remember it, fuzzy. I don't want to go through them all, but this is where it is. If this is something you think you need, you should access it out of your hardcover book, page 109. They also show some trees. As you can see, the trees they are building are of larger numbers this year. Right? Okay. So, first off, a factor. What's a factor? Nobody knows what a factor is? This is a number. Right. Factor. Number in a multiplication problem. We're all in vocab, right? Yeah. Great. Multiplication problem. So, any multiplication problem must have at least how many factors? Two. Right. I mean, if I just write the number 6, well, that's not necessarily a factor until, and then, of course, if you're multiplying, that implies times something, and that equals 30, which we call the product. Right, this is the product right here. The answer to a multiplication problem. And factors, 6 and 5 are factors of 30. There's more factors of 30, though, actually, more than just that here. Prime numbers. Right. We can check it out in a bit. Sure, we can do the. It gets stuck in your head, though. I mean, I'm telling you, if you're going to go down that video path, then you need to be prepared to hear it through the weekend. Hopefully, the football game will drown it out for a little bit, but other than that, you'll be prime.
All right.
Prime. I'm prime. Okay, so anybody have a definition for prime numbers?
Something that multiplies by 1 in itself.
Right, or divides by.
Oh.
Right. As the song goes, prime, I'm prime, P-R-I-M-E. Numbers that divide evenly. Only factors are 1 and me. Right, so there you go. So prime numbers have exactly 2 factors. That's the whole thing. Exactly 2 factors. 1 and itself. And again, you guys rattled off some good prime numbers, but examples like 11. When I go, well, what times what equals 11? You probably go 11 times 1. I go, great, what else? If I said 23, what times what? You go, 23. So this is where those, these things are going to come into play for this lesson here, because you're going to see some numbers like 495. You may not know its greatest common factor off the top of your head, but you should at least, I would think, hopefully be able to conclude it's divisible by 5. Yeah. Right? Right? Because if something's divisible by 5, if it's the one place, it's a 5 or a 0. Right? So you'll have some bigger numbers. You got to be able to figure out, is it prime or is it composite? So prime numbers. Composite.
Even number composite, right?
What?
Isn't every even number except like 2 composite?
That is correct. Yep. 1 and 0 are neither prime nor composite. They're just, there's math, there's memes galore about this out there that, it's a raging battle in the math community of, troll, fun. Anyway, what we all universally agree upon, though, is 2 is the only even number that's prime. And composite, the rest of them are composite. So composite number, if we would define it, not 4, 3. Yeah. 3 or more factors. 3 or more factors. Being able to know if your number is prime or composite is pretty much everything for simplifying. If I write 2/8 and you can't figure out that both of those numbers could be divided by 2, we're going to go through that, well, and then simplify to 1/4, then we got an issue. But composite numbers. So examples, I could say the number 6. So if I say to you, what are the factors of 6? What I'm saying to you is, well, what times what equals 6?
3.
And you may think 3 times 2, but you could, there's also 1 times 6. So if I say, what are the factors of 6, you would say 1, 2, 3, and 6. Prime numbers have exactly 2 factors that divide evenly, 1 in itself. But composite numbers, 3 or more. Again, 1's always an answer here, and then of course 6 divides by itself, but it also divides by 3 evenly, and it also divides by 2 evenly. So therefore it has 4 factors. If I say the number 9, what are the factors of 9?
3, 1, 9.
Yeah, I could say 1, 3. I don't need to write 3 twice. If you write, again, if you want to write them out this way, that's fine. I get it. I just need, somehow I need to see 1, 3, and 9. I don't need to see them in order. You could write them. It doesn't, all this is fine. But if I say, what are all the factors of 9, I would look somewhere to see a 1, a 9, and a 3 out there, right? You need to see all 3 of those numbers. But they all have, and if I pick a number like, say, 24, well, what?
8
8 times 3, 6 times 4, 24 times 1, 12 times 2.
2 times 12.
That's 8 factors right there for that number. So if I say all the factors 24, you got to give me 8 numbers, right? Those are all the things that divide into 24. We'll use all this information, of course, shortly to find greatest common factors. We want to find the largest number that can be divided evenly into 2 numbers. Hence, a fraction that has a top number and a bottom number. So, composite numbers. We build, I think we're good with vocab here. Let's switch over to notes here, because now we're going to build a prime factorization tree. But we need to know the difference between composite numbers and prime numbers if we're going to build a prime factorization tree. And that's exactly what we're going to do. So the first part here, looking at the homework. Homework, you do not need to do 58. So homework is 2 through 56. Okay, you do not need to do 58. All right? Yes? Don't need to do 58? Not necessary. Okay. So we're going to come to the factor tree in a bit, but let's just, when we get there, let's get there. So 1 through 15, tell whether each number is prime or composite. Number 3 says 19. The question is prime or composite. Now, like Dom told us, excellent point, all even numbers except for 2 are composite, all of them, because you think about any of them. 2, the only things it divides by is 1 and 2, but 4 is divisible by 1, 2, and 4. 6 is divisible by 1, 2, 3, and 6. 8 is divisible by 1, 2, 4, and 8. So they all have 3 or more, all even numbers. So with that said, I guess for number 5, you can see most of them are not even numbers. How do you know? I mean, with bigger numbers here, like 211 or 127, how do you know? I mean, you may not know all the factors off the top of your head, or any factors of 211 or 127. So what would you need? Again, you need to apply the rules of divisibility. So I will one time here. You ready for them? I think we know what 2 is. Ends in an even number in the ones column. 3. You add up all the digits, right? And then you see, is that number divisible by 3? 4 is you look at the last two digits, 0, 0, 0, 4, 0, 8, 12, 16, all the way up to 96. The last two digits. 8 is hard. It's the last three digits, multiples of 8. 8's tough. 6 is it's got to be divisible by both 2 and 3. So 2 is easy to check. You just need to check 3 for 6. 9 is just like 3, except when you add up all the digits, the sum needs to be divisible by 9. And then 10, of course, everybody knows if something's divisible by 10. Challenge there. So,
Are we gonna be allowed to have a note card for the testing?
not sure. TBD. Subsequent calculator chapters, though, it's much more likely. Perhaps. We'll see what we all go through here. So, anyway, there we go. 19, what do you think? Anybody? Prime. Prime is prime. Because, again, you test all the rules of divisibility, 2, 3, 4, 5, 6, 8, 10. Truth be told, any number less than 100, for the most part here, the rules of divisibility work just fine. Okay? Yes, Seg.
What do you do for 7? That's not a thing. If they don't have
For 7, number 83.
Yeah, so they don't have it for 7.
no, like the number 7 for dividing into things.
Yeah, so
Right.
you know,
That's exactly what I'm going to tell you right now. So 1 through 100, right? All the numbers apply to the rules except for one. There's one number that is composite, but none of these rules apply for. Anybody know what number that is?
7.
No. Nobody? 91. What times what equals 91?
1 times 91. That's
It's not divisible by 2, 3, 4, 5,
7.
6, 8, 9, or 10.
So it's 7,
divisible by 7 and
14.
13.
13.
Right. So that's the only difficult two-digit number. The rest of them are all. So any of these numbers like 83, I mean, you may not know, but does it divide by 2? No. Some of its digits. What's 8 plus 3?
11.
So that's out. Obviously, if it doesn't divide by 2, none of the other. Does it divide by 5? No, can't be 6 because it's not 8 or 3. 9? Well, if it can't divide by 3, it can't divide by 10. So it must be prime. So it's prime. So you got to run the rules through your head if you're not sure. Outside of 91, which I will consider fair game going forward, that is composite. It could be 13 times 7. Other than that, there'll be no whatever 59 times 7 is or something. It'd be like, 693. It's 59, So, but 91 is composite, okay? All the other two digits are, you can test the rules very quickly. 77, I guess you can't, but most people understand and can see 7 and 11 and 77 without issue. Jackson.
So what if it's a 2-digit number and we have to figure out if 8 goes into it? Because 8, you look at the last 3 digits, but there's not 3 digits.
All we're doing is primer composite. If it divides by 8, well then it certainly will divide by 2. And therefore it's composite, right? So at no point am I going to ask you a question like in 6th grade where I go, tell me all the numbers this is divisible by. Remember you had that, that's not the point of this exercise. So 8 for our purposes is almost inconsequential. Outside of what I told you, 91, here's the deal. All you really need to test are 3 numbers. What 3 numbers do you need to test? That will test all 2, 3,
6.
2, 3, and 5. Because 6 is divisible by 2 or 3. If it divides by 2, or 3 or 5. I mean, every number when you go through this chapter, if you need 2, 3, or 5, that's what you need to ask yourself. 2, 3, or 5. And then there's 91. Okay? 91's special. Okay, you might see 91 in homework, or quiz or test a couple times this chapter. Just remember 91 is 13 times 7.
So 1 through 15, we just say composite or prime.
Yeah, that's it.
Oh.
I mean, number 11, 13, it's 11. That's 5th grade. So, number 11, 315. Is that prime or composite? Brooke?
It's composite.
Right. I don't know all its factors, but clearly it divides by 315 and 1, and I know it divides by 5. Does it divide by anything else? Not that it matters.
5 and 69.
3. It divides
63. It divides by 3. 5 plus 1 plus 3 is 9, which divides by 9, so it divides by 9. Right. But all I need is one of those to, all I need is one number. Guys, all I need is one number and it's composite, right? Right?
Yeah.
Again, keep that info with you later on this lesson. Next part. So, what you're seeing here, boys, girls, what you're seeing here is what your final answers to your trees are going to look like. Again, we're going to do a tree soon. But here's a tree, right? They did 528, and here they are at the bottom, right? So this is, it's broken down to its prime components. If you notice, all these numbers here, for the most part, I don't know what's going on, are generally prime. So 17. And what we're doing here is writing things in exponential form, simplifying. So we need to review what an exponent is. If I write 5 to the 3rd power, what's my exponent? The 3. There's my exponent. 5, what do we call that number? That's my base. That's my base. So what does the exponent tell me to do? Or what do I need to, if I write down what an exponent is, it does what?
Multiply the number by itself.
Right.
What?
I was getting a little loud over there for some reason. An exponent. How many times to multiply the base times itself? So if I have 5 to the 3rd power, that 3, the exponent's telling me how many times to multiply the base, 5 times itself. I'm saying multiply 5 times itself 3 times. 5 times 5 is 25. 25 times 5 is 125. 5 to the 3rd power is 125, or 5 times 5 times 5. So what we're doing here is writing these answers in exponential form. So 2, and then I personally like that more than the dot. But 7's being multiplied by itself twice. Right? I could certainly reference it this way too. The order you write these things doesn't matter. But then it wants me to solve it. So 7 squared is 49. 49 times 2 is 98. So this is one, I wouldn't need to see both, but one or the other. So you're rewriting in exponential form, figuring out what you have in common, get the right exponent up there, then doing the little multiplying problem that you have to do. I'll give you a couple to try. You guys try numbers 21. I'm just going to rate it this way. 23.
33.
27. So write in exponential form, then solve or find the product as it says, which of course is the answer.
You want us to like write all the first parts out for homework?
Huh?
You want us to write all the first
No,
parts out?
no. When you're doing your homework, you do not need to write any of this stuff out here. You can just write prime or composite. You can just write it out in exponential form and solve. You do not need to write any of these problems. Here, though, when it's time to start building some trees, you're probably going to need to write the number down. But no, you do not need to write these out.
Easy catch, Higgle drop. Yo, how far?
I've seen that.
Wait, that's after this video.
Okay. 21. So give me your answer in exponential form, and then you can tell me what the answer actually is. Sig.
Okay, so, 3, squared,
Cubed.
cubed, then 2, times 5, and it equals 135.
135. Right. So quick refresher here. So the 2 and the 3, sometimes they have different names.
Yeah.
But to the 4th power, fifth, we just say 5 to the 4th, 5 to the 8th, 5 to the 13th, 5 to the 20, But the 2 and the 3, you could say 5 to the 2nd power, 5 to the 3rd power. But this one here, we will say squared sometimes. And this one here, it's cubic measurements or cubed, 3-dimensional type measurements. So, not to be confused, again, last thing here, squared is not the same as doubled. Doubling something is multiplying something times 2. Squaring is 5 times 5. 5 doubled is 5 times 2. 5 squared is 5 times 5. One equals 10, the other equals 25. So the words doubled and tripled don't mean squared or cubic at all. One of them means times 3, the other means to the 3rd power. So anyway, just food for thought here. They switch around, especially in geometry. When we're there, we use these terms more frequently with exponents. They're generally referred to measurements. Our DP Juza guys are not familiar with these two words with their work they do, blueprints and stuff like that. So anyway, good sick. 23, Damien.
All right, so 2 to the 4th,
Yep,
and then that's 16.
16. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Good. 27, Dom.
5 squared times 2 squared times 3
Yep,
equals 300.
300, right. 25 times 4, that's 100. 100 times 3 is 300. Good. Feel good about that? All right, turn it over. So, all these rest of these problems are pretty much the same thing here. It is use prime factorization, write your final answer in exponential form. So, regardless of what the rules say up here, the answer is to write your answer in prime factorized form. We'll do,
Do we have to do 34?
yes. You do not need to do it twice, though.
Oh, just do one.
Yeah, all this, you do not need to do the tree twice for 11. So we're gonna do a couple trees and then so 45 is fair. Let's do 45. So I'm looking at 33. And I will discuss with you when we finish here how many trees you must required trees. You may need or choose to do more trees than required, but I need everybody to do some. I will tell you which ones. Others, I'll let you make your own choice. But 45, when I'm making prime factorization trees, at the bottom of every tree is prime numbers. If a number is composite, then it can be factored down further, meaning it has factors other than one in itself. So 45, when I think 45, I think 9 times 5, right? So now I have my 9 and my 5. 5. Is that prime or composite? Prime. So that's part of my answer here. 9. Prime or composite? Composite, which means it has more factors than one in itself. What times what? 3 times 3. So 3. Prime or composite? Right. So these are my numbers at the bottom of the tree. Some people with the tree, you could, if you get lost as the tree gets bigger, what you could do is once you get your prime number, just draw a little stick and just kind of carry it down with you. So everything's on the same line. If I did, just for example, 45, I could have also said 15 times 3, right? So 15 and 3. 3 is prime. Zach, what are you doing?
He's not paying attention.
Yeah.
15, 5 times 3, and look at that. I got 335. So what I'm illustrating to you here is some numbers, there could be some different paths, but what will always be the same with the trees is our bottom numbers will always be the same, no matter what path you take. Because 24, I could start with 6 and 4, I could start with 8 and 3, I could start with 12 and 2. But when it's all done, it's 2, whatever it would be there. What is it there? 8 and 3. 2 cubed times 3. 2 to the third power times 3. Regardless of whether you start with 8 and 3, 12 and 2, or 6 and 4, you'll end up with 2 cubed times 3 at the bottom of your trees. Why don't you guys try number 37, 42. Build a tree. Build yourself a tree. Write your answer, that number right there, 42. Build a tree. It's number 37. Build a tree.
Wait, which number? Number 30.
Write your answer in exponential form.
It's number 37, but the number is 42.
Good boy.
Doesn't really matter what numbers we pick here.
Just one? Just do one tree?
Yep, one tree is good. The objective is if you can write it out, your final answer in exponential form with the right bases and exponents where they should be.
So for 32 through 35, you still want us to do two though, right?
No, one, just one. You don't need to build. They're illustrating this concept to you, right? And I think you understand and illustrate it, and I just verbally talked about the 24 instead of building 3 totally different trees at the top, but they would all end with 2 cubed times 3. That's what they're trying to have you see, but I just showed it to you here. If you can just, again, if you can build a tree and get an exponential form, Jackson, that's what you're going to need to do for the next couple lessons here. Build the tree, and then what do I do with that information? Today is just about building a tree. What do I do with the tree? We'll come back on Monday and Tuesday, and I'll show you what you're going to do next with the tree. Right now, you're just building a tree. My question is, can you build a tree?
So the back page is all just building one tree.
Yeah, but I won't necessarily have you do that all trees. I'll look at it once we're done here. Okay, so 42, 21 times 2, 7 times 6. Most people probably started there. 7 can't be factored any further, but 6 can. So this is just 2 times 3 times,
That's what I did. That.
right? Try the number 120.
Just that number.
Build a tree for that one.
Like, or no, not yours.
There's like no things with two ends. I mean, like, if it's true.
So let's see. You got
Little cat. You do that.
Skittle.
Little cat. Little cat.
Kittle likes a diddle.
Little cat.
Kittle, little diddle.
Little.
Diddle.
Oh!
these 6, do trees for. The other ones, you might have to do trees. These 40, 42, 40, 50, 52, 54. Right, those 6. You're pretty much going to have to anyway. Like, I don't know how you're going to solve it without building a tree. I'm looking at the answers here, and I'm like,
Wait, those
yeah.
numbers or the numbers in the
34 through 54, right? 34 through 54. So numbers 40, 42, 48, 50, 52, and 54. So not those numbers, but 54 is 385. 52 is 171. 50 is 56. So these numbers,
Okay.
these problem numbers, right?
40, 42. That's what we should do.
I already
trees
did
for?
like a bunch.
Do the trees for these.
For the ones that are circled?
Yeah,
in the homework.
right. I'll leave that up there.
Okay.
Okay, I'll leave that up there. You may need to do the trees for all of them, I don't know, but, so I definitely need to see these 6 trees though. Clear
Yeah.
on that? And one more time, you do not have to do 58, so don't do 58. Do not do it. Okay, 120, first thing I think of is 12 and 10. That's what I see. We're going to do one more then after this. 12, I see 4 and 3. 10, I see 5 and 2. And then my 4, of course, should be 2 and 2. So this is where it's a little subjective. I mean, me personally, I see my 5 numbers here.
Oh.
Sometimes when people get to them, they'll like circle them on the way, and then like here they'll just circle them when they're done with them. I've seen some people again, they just do this, they'll just bring the numbers down with them, so all their numbers are just always on one line. It's just, I've seen all 3 methods.
I just do a big circle around.
It's, yeah, I tended to do it like this on my own, but different people got to do it differently. What ultimately matters is I need you to have these 5 numbers here. At this point, basically it's 2 times 2 times 2 times 3 times 5 is what you end up with. But the answer I'm looking for, 2 to the 3rd power times 3 times 5. That's the answer I'm looking for. And again, you may have done your tree differently. So one more. See what you do with this one. There you go.
Oh,
Enjoy.
I will not.
Enjoy.
What?
256.
Anybody know why I picked that number?
Was it
No.
your favorite number?
Cool. You'll know when you're done.
Yes, it was.
So, do I know all the factors of 512 off the top of my head? I do not.
Probably.
Well, you probably do.
Um,
You're smart.
Do I know it divides by 2? Yeah, it's an even number. I could certainly just get to it, divide by 2. Maybe, Damien?
Yeah.
You done with it? You got it?
No, I don't.
Who's that pencil dude?
Oh, one.
Maybe you're feeling more spicy too. Maybe you're like, it divides by 3. And that's your move. You want to divide by 3. Maybe you realize it divides by 4. Or maybe you realize it divides by 2 and 3, so you therefore it can divide by 6. So you have some choices here. But then I guarantee you'll not be finished. You'll have another choice to make.
Oh. There we go.
Then what are you going to do?
Oh, I got it.
And then I kind of guarantee you're going to have another choice after that. So if you get it, you'll if you get it, you'll know why. Pick 512.
Only 2 8 9. I just divided by 2 the whole time.
Yeah. That goes back to the beginning here, where if you can just figure out, does this thing divide by 2, 3, or 5? You can just chunk it down piece by piece. That's no matter how large the number is, 2, 3, or 5, you can just chunk it down to get to a smaller number and then reassess. Eventually, you'll get to, not too long, it'll just be double-digit numbers you're looking at then.
Hey,
All right. We all got it? Anybody know why I picked the number yet?
because you wanted to.
Nobody
Because
knows?
it's probably divisible by some crazy number.
Huh?
Is it divisible by 91?
67.
This is all about getting an
Mr.
exponential
Walter,
form.
You should do a math challenge. You should see who can make the nicest tree out of them. And then you have to figure out the right number to get a good tree out of it, and make a perfect shape for a tree.
I don't get it.
I'm intrigued by this as an extra credit thing for you guys.
Advisors.
I'm intrigued. I'll pursue, I'm interested in discussing. It could be like an extra credit thing or something. No, maybe I'll even toss the 8th graders in on it.
Why?
Why
What
not?
are we doing?
Well, they don't have to. Extra credit fee. Extra, not normal credit. Don't you get tired of all your normal credit?
You gotta make a perfect
Faith?
tree, but it has to be correct.
Evangeline, what was the answer? You don't have to build a tree, but what did you get for an answer?
You need
How is that
the
possible? You need
perfect number to do it.
She got 2 to the 8th power. Anybody else?
I got
Brooke?
that. I got that.
I got 2 to the 9.
2 to the
I got 2
9th?
to the 9. I got 2 to the 9.
2 to the 9th.
Jinx, I got both of you, Dustin.
So,
We did jinx.
guys, shh. I picked this number
I got 2
because.
to the 9.
Okay, yeah, we're gonna work it out here. But I picked this number because it has so many factors that your trees could not all of us could make a totally different tree with how many different choices you have at each step. Ultimately, how do I view it? I don't know. I see 256 and 2. It's just too big of a number for me. I just start small and I continue to go small until I don't know that, but by the time I get to 64, now that's me personally, this is the first time I feel comfortable. I'm like, it's 8 times 8, it's 4 times 2, it's 2 times 2. So I had, and again, however, you could bring these down, just, each step of the way you're carrying. But 1, 2, 3, 4, 5, 6, 7, 8, 9. Or 9 of them. 9 of them out there. So you could have divided by 8. You could have divided by 32. You could have divided it by 64. It had so many different things we could divide it by. Which means, depending what you saw, would change your tree and Anybody else do the 2-2-2 thing for a bit?
I did for a little
what I
bit,
did.
and then I was like,
Well, I did it till I got to 64, and then I
and then
jumped
I,
off and
and
switched.
then I was like,
Nah, I did the exact same thing you did until I got 64, and then I did the 8-8. But I did the exact same thing.
Well, I did 8-8 at 64.
Yeah.
Yeah. So, yeah, I mean, that's honestly how I do it. I mean, I'm probably better at math, but this is still how I would approach this problem right now. I don't know all the factors of this big number, but I know it can divide by 2, 3, or 5. And I'll start with that, get my next number, and most likely that number will be a little more clear to me, right? Okay. You guys are antsy here. So the tree, again, the goal here, write it in the exponential form. Here's the ones I need to see. Are we clear on that? Which ones I need trees for? Yes. Tomorrow or Monday's lesson, Tuesday's lesson, we'll be building trees both days. We will not stop building trees. You have to build them on the quiz. On all of them here. But the reason we did, here's the deal. The trees, again, we're not going to use them much. They're a tool, and you may still, some people will use them a bit. But truly, a lot of these problems, boys, the method is you just know it in your head because your multiplication tables, your division tables are just that developed by 7th grade. That single digit things doesn't, 72 divided by 8. You can just see these things. You can see the multiples and factors in your head. That's not everybody, and that's okay. I'm not saying it's not. But if you are, the prime factor trees aren't necessarily, they're not going to help you. You can do it faster without the trees. But as we've illustrated with some of these numbers here, they're just too big. You need to have another tool. Best tool is in your head. I just can do it in my brain, and some of you can. But if you can't, and where that line is different from different people. If you can't, this needs to be your go-to. And no matter how good you are, myself included, there are numbers that are just going to get too big that I, would have to build a tree for. How else can I do it? So we all need to do it, but it's in a way something that there's a better method. You just need to get better at your multiplying and division. You need to keep practicing. Okay? We got I'll say it, 6 or 6, it's actually 5 or 6, but I'll say 6 or 7 minutes. So take a break. You can play your game for a few minutes. That's